Hello everyone, I am Sudarshan from Tribly Department and I am here to present the topic Interference of Light in Thin Film from the subject Engineering Physics. Before going to the topic, let us see the contents here. Introduction, what is a thin film, cause of interference, conditions for interference, factors affecting interference, applications, conclusion. Let us see the introduction part here. Light reflects from both the top and bottom surfaces of a thin film. The reflected waves overlap and interfere with each other. This interference produces bright and dark fringes or colorful patterns. The thickness of the film and the wavelength of light determine the pattern. The angle at which light hits the film affects the colors and fringe positions. Thin film interference is used in anti-reflection coatings, optical filters, and measuring film thickness. Let us discuss what is a thin film. A thin film is a very thin layer of material, often with a thickness comparable to the wavelength of visible light. It can be made of liquid, solid, or gas and is usually deposited on a surface. When light hits a thin film, some light reflects from the top surface and some from the bottom surface. These reflected waves can interfere with each other, producing bright and dark fringes or colorful patterns. Thin films are widely used in optical coatings, mirrors, lens, and sensors. Let us discuss the cause of interference. The cause of interference in a thin film is the superposition of light waves reflected from the top and bottom surfaces of the film. These waves combine to produce constructive interference or destructive interference depending on their phase difference. The phase difference is caused by the extra distance traveled by the wave inside the film and by any phase change during reflection. The resulting interference produces colorful patterns or fringes, which are commonly used in soap bubbles, oil films, or anti-reflective coatings. You can see the diagram here. And coming to the conditions for the interference. Condition for bright fringe. 2n equals to m plus 1 by 2 into lambda. Here, T equals to thickness of the film and n equals to refractive index of the film, where lambda equals to wavelength of light in air and m equals to 0, 1, 2 and so on. The form depends on whether there is a phase change upon reflection. If there is a phase change of pi at one surface, use 2nt equals to m plus 1 by 2 into lambda. And coming to the condition for dark fringe, 2nt equals to m lambda. Use the opposite case of bright fringe depending on the phase change of reflection. Let us see the factors affecting interference. The thickness of the film affects the path difference between reflected waves and thus the interference pattern. The wavelength of light determines which colors appears in the interference fringes. The refractive index of the film changes the speed of light in the material and affects the phase difference. The angle of incidence of light changes the effective path length and shifts the fringe positions. Finally, phase changes on reflection at boundaries of different refractive indices influence whether the interference is constructive or destructive. And let us see the some of the applications here. Anti-reflection coatings are used on glasses, camera lens, and optical instruments to reduce unwanted reflections. Optical filters select specific wavelengths of light for cameras, lasers, and scientific instruments. Soap bubbles and oil films show colorful patterns due to thin film interference, which is often used for educational demonstrations. Interference patterns helps measure the thickness of thin films in industries and laboratories. Thin film interference is also used in making high reflectivity in telescopes and lasers, as well as in sensors like pressure, biosensors, etc. And finally, the conclusion. Interference in thin film occurs due to the combination of reflected light waves causing bright and dark fringes. It explains natural phenomena like colorful patterns in soap bubbles and oil films. This principle is used in practical applications such as anti-reflective coatings and measuring film thickness. Thank you.